Okay, you guys, it's time for lesson 5.2. What we're doing today is understanding the converse of Pythagorean theorem and to determine if a triangle is acute or obtuse based on its measures. Okay, so for the warm-up, we need to determine if the following sets of numbers are Pythagorean triples. Remember, your largest one is always going to be your hypotenuse. It just happens to be the third one in the row on each of these, so that's good. So I would do 14 squared plus 48 squared equals 50 squared. 14 squared would be 196 plus 2304 equals 2500. 196 plus 2304 is 2500 equals 2500. So yes, that is a Pythagorean triple. The second one would be 9 squared plus 40 squared equals 41 squared. That's going to be 81 plus 1600 equals 1681. 1600 plus 81 is 1681 equals 1681. So yes, that is a Pythagorean triple. Last one, 12 squared plus 43 squared equals 44 squared. 12 squared is 144 plus, that's kind of a big number. I don't have that one memorized. 43 squared is 1849 equals 44 squared is 1936. And then I need to add 144 plus 1849, and I get 1993. That does not equal 1936. So no, those numbers are not a Pythagorean triple. Okay, now we're going to simplify the radicals, okay? This means 5 square root 12 squared. So in other words, 5 times 5 is 25. Square root 12 times 12 is 144. Square root of 144 is 12. So that comes out to get multiplied by 25. And my answer is 300. B is 14 over square root 2. I cannot have a radical in the bottom. I cannot simplify these because one is outside the sign and one is inside. So the only thing I have to do is multiply by square root 2. And up top, that will give me 14 square root 2. And on the bottom, that will give me square root 4, of which now I can simplify that to be 2, okay? So now I'm looking at 14 square root 2 over 2. They didn't give us a whole lot of room, did they? Now I can actually simplify 14 and 2. Just remember, what's outside goes together, what's inside goes together when you're looking at it as far as simplifying like a fraction, okay? Both of these can be divided by 2. That's going to be 7, and this is going to be 1, which means my denominator will go away, and my final answer is 7 square root 2. Okay, 18 divided by square root 3. Okay, again, I can't do anything except multiply top and bottom. So that'll be 18 square root 3. The bottom will be square root 9. Square root of 9 simplifies to 3. So then I have 18 square root 3 over 3. Now, 18 and 3, again, think about that as a fraction. These can both be divided by 3. I'll have 1 on the bottom and 6 up top. Anytime you have 1 as a denominator, it can go away. Unless you're talking about ratios, then you have to have the 1. So my final answer would be 6 square root 3. Okay, now, what we've been talking about so far with Pythagorean theorem is that we can find missing sides, okay? Or we verify the fact that something is, in fact, a right triangle or not, okay? So the converse of that simply tells you that if these two, if a and b squared equals c squared, then yes, you're dealing with a right triangle. Okay, so for example 1, they give us these sides here, okay? And when you look at those, you may be wondering, oh, I'm not exactly totally sure which one of these is going to be the hypotenuse. You can kind of tell, though, honestly, that this one would be your hypotenuse. It is larger, okay? If you're ever not sure, you could always convert that to a decimal. You just put it in your calculator, and then you could compare it to 16 and 8 if you weren't sure, okay? But now let's go ahead. So this is going to be my C. So 8 squared plus 16 squared equals 8 square root 5 squared, which means you'll have 64 plus 256 equals 64, because 8 times 8, and then 5 times 5, okay? Now, you have to simplify this, because square root of 25 is 5. So these are both outside the sign now. So you have 64. Well, I guess I could go ahead and add these. 64 plus 256 equals 320. And then 64 times 5 also equals 320. So yes, it is a right triangle. Okay, so far so good. All right, now take a look at this one. Remember, I told you the largest side is always going to be your hypotenuse. So let's set this one up. 22, make sure I got on the camera here, 22 squared plus 24 squared equals 26 squared. 22 squared is 484 plus 24 squared is 576 equals 26 squared, 676. 484 plus 576 equals 1060. That does not equal 676. So my answer is no. That is not a right triangle. Even though I know it kind of looks like it by the picture, you can't go by that. You have to go by the measures. Okay, example 2. Do the following lengths make a right triangle? Now this is real similar. This is real similar to what we did before. I don't know why that always takes that little tail off of there. That kind of bugs me. Okay, and in this case, on all of these, your very last one is your hypotenuse, okay? If you weren't sure though, let me just show you, okay? You would do, what is the square root of 5, just like normal, square root of 5, okay? It's 2.23, okay? That one's 3, and then do the square root of 14, which is 3.74, okay? So this is 2, this is 3, and this is 3.74. So then that way you know, in fact, that one is the biggest, okay? And I'll double check on that, but that's how you can know for sure. So if you ever have a question like that, you could do the same thing here with 2 square root 3, okay? You can put that into the calculator, 2 square root 3, convert that to a decimal. It's actually 3.4, okay? But again, that's smaller than 8, so you know these two equal this when you're set. Oh, sorry, my hand's right in the way. These two will equal this. As long as it's smaller than 8, these two would be fine because you have to have the largest one be your hypotenuse. Okay? All right, let's set these up. Let's see. I'm going to have 5 squared plus 3 squared equals 14 squared. This would be square root 25 plus 9 equals square root 196. Okay, I know that that's going to be 5 plus 9 equals 14. 5 plus 9 is 14 equals 14. So yes, it will make a right triangle. Okay, let's do the next one. 6 squared plus 2 square root 3 squared equals 8 squared. 36 plus, just remember it's each of these times itself. 2 times 2 is 4. 3 times 3 is 9 equals 64. This one I need to go ahead and change. 4 is outside. Square root of 9 is 3. So that's going to be 36 plus 12 equals 64. 36 plus 12 is 48. That does not equal 64. So no, this is not a right triangle. Last one. 3 square root 2 squared plus 4 square root 2 squared equals 5 square root 2 squared. Whew. It's going to be 9 square root 4 plus 16 square root 4 equals 25 square root 4. Hopefully you know that that is 2. So each of these will be multiplied by 2 to simplify that radical. 9 times 2 is 18 plus 16 times 2 is 32 equals 25 times 2 is 50. So 18 plus 32 is 50 equals 50. So yes, that would make a right triangle. Okay, now the next thing we're going to do is we're going to talk about identifying acute and obtuse. Okay, and I know most of you think that you can tell just by looking at it, but no, you don't want to do that. Not so much. Okay, so this is how you do it. You're still going to set it up as in using a squared plus b squared, okay, and then have c squared over here, all right? But if your c squared winds up being smaller than that, okay, I messed that sign up just a little bit, didn't I? So if a squared plus b squared is greater than c, then your triangle is acute. Okay? So, in other words, if you want to write it in easier terms, okay, if c squared is smaller, it's acute. Okay? And then the same thing with obtuse. Okay? If you have a squared plus b squared, and that is less than c squared, then your triangle is obtuse, okay? Or if you want to write it out, if c squared is larger, it's obtuse, okay? So it's not difficult, just go slow. That's probably my number one thing. All right, let's take a look at this now to determine if the following triangles are acute, right, or obtuse. So you're just going to use that same formula, a squared plus b squared equals c squared. Now, when you look at this, you might be thinking, oh, I don't know. How am I going to know which one is bigger? Okay, just put 3 square root 5. Let me do that now. Into the calculator, okay? and you get 6.7, zeros, some other stuff, okay? So that just lets you know this is bigger, okay? 8's going to be my C, so set it up like that. You can't use the decimal to calculate it, but it's just to let you know which one is larger, okay? So 6 squared plus 3 square root 5 squared equals 8 squared. 36 plus 3 times 3 is 9. 5 times 5 is 25 equals 64. Now, what you want to do here is you will simplify before you move on. Square root of 25 is 5. So you'll have 36 plus 9 times 5 is 45 equals 64. 36 plus 45 is 81. 81 is greater than 64. So when this is greater, in other words, if C is smaller, it'll be acute. Okay? If C is smaller, your triangle is acute. All right, let's take a look at the next one. This one's a little bit easier because it doesn't have radicals, but you can tell this one would be your hypotenuse. So 14 squared plus 15 squared equals 21 squared. 14 squared is 196 plus 225 equals 21 squared is 441. 196 plus 225 is 421 and 441. Now take a look at that. Obviously, 441 is greater than, and if C is greater, then it's obtuse. So this would be an obtuse triangle. And notice, looking at the picture, you can't really tell because it really kind of almost looks like a right triangle. So you cannot just base it on how it looks, okay? Don't do that. Just plug it in. This is not very difficult. Just use the same formula, okay? Just go slow, take your time. And this concludes our lesson.